Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on speed. So they are questions involving speed, distance and time. If you need any extra help on speed, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 299, there's a dedicated video tutorial there on speed. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at our first question, question number 1. So question number 1 says a car drives 120 miles in 3 hours, and we've been asked to calculate the average speed in miles per hour of the car. So we want to find the average speed of the car in miles per hour, so we want to find out how many miles it would drive in 1 hour. So if it drives 120 miles in 3 hours, we could just divide that by 3 to find out how many miles it should drive in 1 hour, and then that would be the speed of the car in miles per hour. So the speed is equal to the distance divided by the time. So let's take the distance, 120 miles, and divide that by the time, which is 3 hours, and 120 divided by 3 would be equal to 40. So that means that the speed of the car, the average speed of the car is 40 miles per hour, and that's it. So the speed of the car is 40 miles per hour. And we just worked that out because we know if the car drives 120 miles in 3 hours, it would drive 40 miles in 1 hour, so that means the speed is 40 miles per hour. Okay, let's look at our next question, question number 2. So question number 2 says a lorry travels 100 miles at an average speed of 25 miles per hour. Work out how long this journey lasts. So we want to find out how long the journey would last. Now if it drives at a speed of 25 miles per hour, that means it drives 25 miles every hour. And if it drives 100 miles, if we just divide 100 by 25, that'll tell us how many hours it should take. So we could count up in 25s and say 25 plus another 25 is 50, plus another 25 is 75, plus another 25 is 100. So it would take the lorry 4 hours to do the journey. So the journey would last 4 hours. Another way to do it is to just say, well, the time is equal to the distance divided by the speed. So if you divide the distance, 100, by the speed, 25 miles per hour, that's equal to 4. So that means it'll take the lorry 4 hours to complete the journey. And that's it. Okay, let's take our next question, question number 3. Okay, question number 3. Question number 3 says a pigeon flies for 7 hours at a speed of 70 kilometers per hour. Calculate how far the pigeon flies. Well, it flies at a speed of 70 kilometers per hour. So every single hour it flies 70 kilometers. And it flies for 7 hours. So that's going to be 7 lots of 70. So if we do 7 multiplied by 70, so 7 lots of 70, 7 times 7 is 49. Then there's a 0 on the end, so it's going to be 490. So that means the pigeon would fly 490 kilometers. And that's it. So if the pigeon flies at a speed of 70 kilometers an hour, and it flies for 7 hours, there's going to be 7 lots of 70, which is 490 kilometers. And that's it. Or another approach is to know that the fact that the distance is equal to the speed times the time. And if you take the speed 70 and times it by the time 7, that'll tell you the distance, 490. So that's it. Okay, let's look at our next question, question number 4. So question number 4 says Matthew jogs 300 meters at 4 meters per second. Calculate how long it takes Matthew. Okay, so he travels the distance, or he jogs the distance of 300 meters, and his speed is 4 meters a second. That means that every single second he runs 4 meters. So if we divide 300 by 4, that'll tell us how many seconds it should take, because every single second he runs 4 meters. So if we just see how many lots of 4 meters going to 300 meters, that'll be how many seconds it would take. So we just take the 300 and we divide it by 4. And dividing by 4 is quite straightforward. You can just half it and half it again. So half of 300 is 150, and half that is 75. So it should take Matthew 75 seconds, and that's it. Or another way to do it is, if you want to work out the time taken, you just take the distance and divide it by the speed. So if you take the distance, which is 300, and divide it by the speed, 4, and do 300 divided by 4, that's equal to 75. Okay, let's look at our next question, question number 5. So question number 5 says a helicopter flies 240 miles in 2 hours 30 minutes. Calculate the average speed in miles per hour of the helicopter. Okay, so we want to find the average speed of the helicopter. So if we want to find the speed of the helicopter, the speed would be equal to the distance divided by the time. So if we divide the distance by the time taken, it'll tell us the speed. Okay, so the distance is going to be 240. So we're going to do 240. And we're going to divide that by the time taken. That's in miles per hour. So we want the time in hours. So we've got 2 hours and 30 minutes. Now 30 minutes is half an hour, so this is actually 2.5 hours. If you've got 2 hours and 30 minutes, that's 2.5 hours, 2.5 hours. So in terms of the time, we're going to use 2.5, 2.5 hours. So if we do 240 divided by 2.5, that'll tell us the average speed of the helicopter. So if we do 240 divided by 2.5, that's equal to 96. So that means the speed of the helicopter, the average speed of the helicopter, is 96 miles per hour. And that's it. And we can check our answer if we take the speed 96 miles per hour, so 96 miles every single hour, and we times that by 2.5, so 96 times 2.5, that's equal to 240. So the helicopter would fly 240 miles in that time. Okay, let's have a look at our next question, question number 6. So question number 6 says, Harry cycles 8 kilometres in 30 minutes. Calculate his average speed in kilometres per hour. Now this question is actually quite nice because he cycles 8 kilometres in 30 minutes, which is half an hour, and we want to find out his speed in kilometres per hour. So if he cycles 8 kilometres in half an hour, in a full hour, he would cycle 16 kilometres. So that means that his average speed is 16 kilometres an hour because we know that he cycles 8 kilometres in half an hour. Well, in a full hour, that would be 16 kilometres. So that means his speed is 16 kilometres an hour, and that's it. Or another way to do this question was to actually say, well, speed is equal to distance divided by time. The distance is 8, and the time is, well, 30 minutes is half an hour, so that's 0.5 hours. And 8 divided by 0.5, well, so how many halves go into 8? Well, there's 16 halves in 8, so the answer would be 16. So the answer is 16 kilometres an hour. Okay, let's have a look at our next question, question number 7. So question number 7 says, Arlo drives from Coventry to Shrewsbury at an average speed of 42 miles per hour, and the journey takes 1.5 hours. Calculate the distance from Coventry to Shrewsbury. So we want to find the distance travelled. So we know the time taken, 1.5 hours or 1.5 hours. And we know the average speed is 42 miles per hour. So if we want to find the distance, well, to find the distance, well, it's 1.5 hours. That's going to be one lot of 42 because it's 42 miles every hour. So we've got 42 miles. That's for the hour. And then we've got half an hour. Well, it's 42 miles per hour. So in half an hour, the car would travel 21 miles. And then if we add them together, 42 plus 21 is equal to 63. So that means that Arlo has driven 63 miles. And just to recap that, we know the speed was 42 miles per hour. So in 1 hour, the car would travel 42 miles. So that's 1 hour. We know it's an hour and a half. So in half an hour, it's travel 21 miles. And 42 plus 21 is equal to 63. And that's it. So that's one way to do that question, just using a bit of common sense, just understanding what miles per hour is. So it's how many miles every hour and working out that way. Another way is actually to just use the formula that the distance travelled, the distance would be equal to the speed times the time. So if you take the speed and multiply that by the time, you get the distance. The speed is 42, and we're going to times that by the time taken, which is 1.5 hours, so 1.5. And we just need to do 1.5 times 42. And to do 1.5 times 42, I would do 1 times 42, which is 42. I would do a half times 42, which is 21. And then I would add them up. 42 plus 21 is equal to 63. So 42 times 1.5 would be 63. Just doing 1 times it and a half times it and then adding it together. And that's it. Now, there was another way to do that multiplication. We could actually do 1.5 multiplied by 42 and work it out that way if you wanted to. So put the decimal point down and do 2 times 5 is equal to 10. Put the 0 down, carry the 1. 2 times 1 is equal to 2 plus 1 is equal to 3. Okay, now we're going to times by the 40 to put the 0 down. 4 times 5 is 20. Put a 0 down, carry our 2. 4 times 1 is equal to 4 plus 2 is equal to 6. So then we'll add these up and we'll get that's equal to 63 miles as well. So that's it. So we're asked to work out the distance from Coventry to Shrewsbury. The answer is 63 miles. Okay, let's look at our next question, question number 8. So question number 8 says, Edith leaves her home at 11:50 a.m. and she travels 75 miles at an average speed of 30 miles per hour. And we've been asked, what time does she finish the journey? Okay, so we know here the distance she travels and we know the speed. So let's work out the time, how long it takes. So the time taken will be equal to the distance divided by the speed. So we'd see how many lots of 30 miles go into 75 miles, see how long it would take. So let's do that. So let's do the distance, which is 75, divided by the speed, which is 30. And if we do 75 divided by 30, we could use the bus shelter method if we wanted to. So how many 30s go into 7? 0 remainder 7. How many 30s go into 75? That'd be 2, that's 60. Put a decimal point and some zeros and carry on our bus shelter method, or carry on our bus shelter and put a decimal point above. So the remainder there, how many 2s, so how many 30s went into 75? That was 2, remainder 15. And how many 30s go into 150? That's 5. So that'll be 2.5. So it takes Edith 2.5 hours. Another way to do it is to say, well, an hour would be 30 miles, 2 hours would be 60 miles, and another 15 would be half an hour, so that's 2.5 hours as well. So the journey takes Edith 2.5 hours. Now she leaves home at 11:50. Now I'm going to do a bit of a timeline here. She starts at 11:50, so 11:50 a.m. It then takes 2.5 hours, so 2 hours. So if we add 2 hours, that would bring it to, well, we'd have 12:50 p.m., 1:50 p.m., so 1:50 p.m. That's adding on 2 hours. And then another 30 minutes, adding on 30 minutes would be equal to 2:20 p.m. would be equal to 2:20 p.m. So what time does she finish the journey? 20 past 2 in the afternoon, and that's it. Okay, let's have a look at our next question, question number 9. So question number 9 says, Fiona drives for 4 hours and her average speed is 25.5 miles per hour. How far does Fiona drive? So her speed is 25.5 miles per hour. So that's 25.5 miles each hour. And she drives for 4 hours. So we just need to do 4 lots of 25.5. So we just need to do 25.5 multiplied by 4. And that tells how many miles Fiona drove. So let's double it and double it again, because multiplied by 4 we can just double it and double it again. Doubling 25.5 would be equal to 51, and doubling that would be 102. So it would be 102 miles, and that's it. So she drove 102 miles, and that's it. Okay, let's look at our next question, question number 10. Question number 10 says a plane travels at an average speed of 550 kilometers per hour, and the plane travels 3,300 kilometers. Work out how long the plane journey took. Okay, so the average speed of the plane is 550 kilometers per hour. So every hour it flies 550 kilometers, and it travels 3,300 kilometers. So if we just count up in 550s, it's a non-calculator question. Hopefully 3,300 will be in that list of multiples. So let's do that. Okay, so that means in 1 hour it'll fly 550 kilometers. In 2 hours, 1,100. In 3 hours, 1,650. In 4 hours, 2,200. In 5 hours, 2,750, and then in 6 hours, 3,300 kilometers. So it'll take the plane 1, 2, 3, 4, 5, 6 hours. So the plane journey took 6 hours, and that's it. So we just consider the fact that on average it flew 550 kilometers each hour. So we just count up the multiples of 550 until we got to 3,300, and that'll be how long the plane journey took. Or also you could have just said, well, the time is equal to the distance divided by the speed. So we're going to divide the distance by the speed, and that's equal to 6. And that's it. Okay, let's look at our next question, question number 7. So question number 7 says the distance between two cities is 2,898 miles, and a plane journey took 6 hours. Calculate the average speed of the plane. So the speed is equal to the distance divided by the time, or how many miles per hour. So if it flies 2,898 miles in 6 hours, we need to see how far it would fly in 1 hour to get the average speed. So let's divide the distance by the time. So speed is equal to distance divided by time. So 2,898 divided by 6. So how many 6s is going to 2? 0, remainder 2. How many 6s is going to 28? That'll be 4, remainder 4. How many 6s is going to 49? Well, 6 times 8 is 48, so that'll be 8, remainder 1. And how many 6s is going to 18? That's 3. So that means the average speed of the plane would be 483 miles per hour. So that's the average speed of the plane, 483 miles per hour. And that's it. Okay, let's look at our next question, question number 12. So question number 12 says, Thomas drove from junction 2 to junction 3 on a road, and the distance between the junctions is 12 miles, and it takes him 15 minutes. Hannah drove from junction 2 to junction 3 on the same road, so she drives the same distance, which will be 12 miles as well. And she drove at an average speed of 50 miles per hour. And the question says, who has the faster speed? Explain your answer. So we want to find who's got the fastest speed here. Okay, so in terms of Hannah, we know that she drives at a speed of 50 miles per hour, so we know her speed. Her speed is 50 miles per hour. Let's find Thomas's speed. So Thomas drove 12 miles in 15 minutes. There's a few approaches we could use here, but it is a non-calculator question. So the approach that I would typically use for a question like this would be, if Thomas drove 12 miles in 15 minutes, we ideally would see how far Thomas would drive in 1 hour. So in a quarter of an hour, it's 12 miles. If we double that, that would be half an hour, 30 minutes. So doubling that would be 24 miles in 30 minutes. So 24 miles in 30 minutes. So it's double the time, because it's double the time, so it'll be double the distance. And then if we double again, that'll be in 1 hour. So let's double again and see how far Thomas drove in 1 hour. So if we double 24, that's equal to 48. So that means that Thomas would have driven 48 miles in 60 minutes. So that means that he drives at a speed of 48 miles per hour. So 48 miles per hour. So sometimes whenever you're trying to find speed, it can be easier to find out how far someone would drive or travel in an hour. And then that would be the speed, because it's 48 miles every hour. So it's 48 miles per hour, and that's his speed. So that's one approach. Another approach would be to do the distance divided by the time and change the time into hours, which is 0.25 hours. And then you've got to do 12 divided by a quarter. So 12 divided by a quarter. And you could do it that way, 12 divided by a quarter. And to do this, like on a calculator question, it's quite nice. You can just do 12 divided by a quarter. Another way you could say is, well, how many quarters are there in 12? Well, in 1, there's 4 quarters. So in 12, there'd be 48 quarters. So that's equal to 48. So 48 miles per hour. But the question says, who's the faster speed? But the answer is Hannah. Hannah's got the fastest speed. And let's explain that. And that's it. I've just explained that Hannah has the fastest speed because she's traveling at 50 miles per hour and Thomas is only driving at 48 miles per hour. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at our next question, question number 13. So question number 13 says, Roger drives for 2 hours and 15 minutes at an average speed of 36 miles per hour. How far does Roger drive? Okay, so to do this question, what I'm going to do is I'm going to change the time into hours, because at the minute it's hours a minute, so I'm just going to change it into hours. So we've got 2 hours, and then point, and then 15 minutes is a quarter of an hour, and a quarter, remember, is 0.25. So that'll be 2.25 hours. That's how long Roger was driving for. And his average speed is 36 miles per hour, so every hour he drives 36 miles. So if we take his speed, which is 36, and we times it by 2.25, that'll tell us how far Roger drives. So if we take the speed and times it by the time, that'll give us the distance. So 36 multiplied by 2.25 is equal to 81. So that means that Roger drove 81 miles, and that's it. Now that's how I would approach it on a calculator question. I would change that to 2.25 hours and then just do 2.25 lots of 36, and that's equal to 81. That's how I'd do on a calculator question. If that was a non-calculator question, I would do 2 lots of 36, which is 72 miles. And then 15 minutes is a quarter of an hour, and if you do 36 divided by 4, that's equal to 9. And then if you take the 72 and the 9, you could add them together, and that's 81. But that's how I'd do on a calculator question. Okay, let's have a look at our next question, question number 14. So question number 14 says, Martin runs 2 kilometers in 2 minutes. Calculate his average speed, and we've been asked to give our answer in meters per second. Okay, so I'm going to write down what we've been told, that he runs 2 kilometers in 2 minutes. Okay, and I'm going to change that into how many meters. I want to find out how many meters he'd run in 1 second, and then that'll be his average speed in meters per second. Okay, so it's 2,000 kilometers. Now we want it in meters, so let's change it into meters. In a kilometer, there's 1,000 meters. So in 2 kilometers, there's 2,000 meters. So 2,000 meters in 2 minutes. So that means that Martin would run 2,000 meters in 2 minutes. Okay, now to meters per second. So let's change the minutes into seconds. So a minute is 60 seconds. That'll be 120 seconds because there's 2 minutes. So that means that Martin has run 2,000 meters in 120 seconds because it's 2 minutes. Now we're nearly there because we want to know how many meters he runs every second, his meters per second. So let's now divide by 120 and find it for 1 second. So if we divide by 120, we can then find out how far Martin would run in 1 second, and that's his speed in so many meters per second. So if we do 2,000 divided by, if we divide by 120, that's equal to 16.6666 and so on, or 16 2/3 meters per second. So that means that every second Martin would run 16 2/3 of a meter, or 16.666 and so on. So 16.6 recurring. And that's it, that's his speed. So just to recap, we wrote down that he ran 2 kilometers in 2 minutes. We then changed that to 2,000 meters in 2 minutes. We then wrote that as 2,000 meters in 120 seconds, and then we just divided by 120 to see how far he would run in 1 second, which is 16.666 and so on meters, and that's it. Now, one thing I just want to note about this question is Martin's speed is 16.666 and so on meters per second. That means that if he was to do 100 meters, it would take him 6 seconds. So perhaps Martin, by the way, isn't a human. Perhaps he's a horse or a dog or something like that, something that's quite fast, a cheetah. I'm not too sure. But I just want to mention that that's a very fast speed. Okay, let's have a look at the next question, question number 15. Okay, let's have a look at our next question, question number 15. So question number 15 says that Victoria walks 11 kilometers at a speed of 4 kilometers per hour. And the question says, how long does it take Victoria? And we've been asked to give her answer in hours and minutes. Okay, so she walks 11 kilometers at a speed of 4 kilometers per hour. So what we need to do is we need to divide the distance by the speed to see how long it would take. For instance, if she walked 8 kilometers, we would do 8 divided by 4, and that's equal to 2 hours. So here we're going to do 11 divided by 4. We're going to do the distance divided by the speed. And 11 divided by 4 is equal to, 11 divided by 4 is equal to 2.75 hours. So that means that it would take her 2.75 hours. So I'm just going to write the 2 here because we know it's 2 point something, so it's going to be 2 hours and so many minutes. Now to find out how many minutes this is, well, it's 0.75, which is 3/4. Remember that 3/4 is equal to 0.75. So that means 2 3/4 of an hour. And 3/4 of an hour would be 45. If you think of 3/4 of an hour, that would be 45 minutes. So that's 2 hours and 45 minutes. And that's it. And one thing I would say, it'd be quite useful to know some of those decimal hours as how many minutes they would be. So for instance, 0.5, that's half an hour, so that'd be 30 minutes. If it was 0.25, that's a quarter of an hour, so that's 15 minutes. 0.75, that's equal to 45 minutes, and so on. But sometimes you might encounter a sort of a bit of a messier decimal, where it's maybe like 2.711 and so on, and you might need to change that into minutes as well. So to do that, what you would do is, so here we know it was 2 hours, so that's fine, we could just write the 2 down, but then you're left with 0.75 or 0.75. And then if you just multiply that by 60, how many minutes are in an hour? If you do 0.75 times 60, that's equal to 45. Remember, it's a calculator question, so you could do that. So if you had, for instance, something like 0.95 of an hour, you could multiply that by 60, and you could do 0.95 times 60, and you get that's equal to 57 minutes, and so on. So it can be quite useful to know how to change those decimal parts of hours, so 0.75 into minutes. Sometimes you might just know it, but if you're not sure, you could just take the decimal part and times it by 60, and it'll convert it from hours into minutes for you. Okay, let's have a look at our next question, question number 16. So question number 16 says, a car travels 240 kilometers in 3 hours and 20 minutes. Calculate the average speed of the car in kilometers per hour. Okay, so we want to find the speed, which is the distance divided by the time. So we're going to do the distance, which is 240, divided by the time taken. Now, it's not just 3 hours or 4 hours here, it's 3 hours and 20 minutes. So we need to change this minutes into hours. So let's write this time as hours. So it'll be 3 hours, so it's going to be 3, and then point, and then we've got 20 minutes. Now again, that's another one that can be quite useful to learn, because 20 minutes is a third of an hour, because it's a third of a whole hour. And a third as a decimal number would be a third, which is 0.33333, and so on. It's 0.3 recurring. Okay, so it can be quite useful to know that 20 minutes is a third, which is 0.33333, and so on. Or you could take the number of minutes, which is 20, and just divide it by 60, how many minutes are in 1 hour, and you get that's equal to 0.333, and so on. So you could then just write 3 and then 0.333, and so on. So for instance, if it was 4 hours and 7 minutes, you'd write 4 point and then take the 7 minutes and divide it by 60, and that'll give you the decimal bit that goes after the 4. Okay, so we now know that the car travels 240 kilometers in 3.33333 and so on hours. So we just need to divide the distance by the time, 3.3333 and so on, and see what we get. So if we type this into our calculator, 240 divided by 3.333 and so on, and I'm just going to type in loads of 3's, and I get that's equal to 72. So it's 72 kilometers per hour, and that's it. That's the speed of the car, 72 kilometers per hour. Okay, let's have a look at the next question, question number 17. So question number 17 says, Richard drives 110 miles to the hotel, and his journey takes 2.5 hours, and we've been asked to work out his average speed. So we want to find his speed. So the speed is equal to the distance divided by the time. If we divide the total distance by how long it takes, it'll tell us the speed. In this case, how many miles per hour. So if we take the distance, which is 110, and we divide that by the time taken, which in this case would be 2.5 hours, because that's 2.5 hours, just changing the fraction to a decimal. If we do 110 divided by 2.5, that'll tell us the average speed. Okay, now we just need to do 110 divided by 2.5. That's a non-calculator question, so we need to do this without a calculator. If it was a calculator question, you could just do 110 divided by 2.5 and get the answer. Here, what I'm going to do is, rather than doing 110 divided by 2.5, I'm going to times both these numbers by 10. And that would give me 1,100 divided by 25. Because if you multiply both the number you're dividing and the number you're dividing by, both by 10, you'll still get the same answer. For instance, if we had 4 divided by 2, that's equal to 2. And if we times them both by 10, we get 40 divided by 20, which is also equal to 2. So if you're multiplying both the number you're dividing and the number you're dividing by, both by 10, then you'll still get the same answer. So we're going to do 1,100 divided by 25. So 1,100 divided by 25. So how many 25s go into 1? 0 remainder 1. How many 25s go into 11? 0 remainder 11. How many 25s go into 110? So that'd be 4, that's 100, so 4, remainder 10. And how many 25s go into 100? That's 4. So that's equal to 44. So that means the average speed, Richard's average speed, is 44 miles per hour. 44 miles per hour. And that's it. Now, also with this division, there may have been other approaches that you would use, and as long as you get 44 for that division, that's totally fine. Okay, let's look at our next question, question number 18. So question number 18 says, the distance from Leek to Milton is 310 miles, and a train travels this distance in 4 hours and 15 minutes, and we've been asked to calculate the average speed of the train. So to work out the speed of the train, we're going to do the distance divided by the time. So speed is equal to distance divided by time. So the distance the train travels is 310 miles. And then we're going to divide that by the time. Now the speed is in miles per hour, so let's change the time into hours. It's 4 hours and 15 minutes. 15 minutes is a quarter of an hour, so it's going to be 4 and then 25 for a quarter, 4.25. So 4.25 hours. So 4 hours and 15 minutes is 4.25 hours. So we're going to do the distance, which is 310, divided by the time, which is 4.25, 4.25 hours. And that's equal to, and it's a calculator question, so we can get our calculator here and do 310 divided by 4.25, and that's equal to, comes up initially as 1,240 over 17. I'm going to change it to a decimal number, so that would be 72.94117647. And that's it. And I'm going to round the speed to 2 decimal places, so the speed is 72.94 miles per hour to 2 decimal places. And that's it. So that's the speed of the train. Okay, let's look at our next question, question number 19. So question number 19, we've got this sign, and it says Belfast, 20 miles. And then the question says, a village is 20 miles from Belfast. Connor drives from the village to Belfast at 40 miles per hour. And Kelly drives from the village to Belfast at 50 miles per hour. And the question says, work out how much longer the journey takes Connor, and to give your answer in minutes. Okay, so that makes sense because Connor's driving at 40 miles per hour and Kelly's driving at 50 miles per hour. So Kelly's going to get there quicker. She's driving at faster speed. So that means it's going to take her less time to get there. So it means it's going to take Connor a bit longer to get there. And we've been asked to work out how much longer it's going to take him. So let's find out how long it'll take each of them to get to Belfast. So to find how long it's going to take, we'll take the distance and divide it by the speed. Because for instance, actually you can look at this and say, well, if Connor's driving at 40 miles per hour, to drive 20 miles, that'll take half an hour because a full hour, he can drive 40 miles. So in 30 minutes, he can drive 20 miles. So I've actually been able to spot that one straight away. It's going to take him 30 minutes to get to Belfast. But another way we can do it is to work out that the time a journey should take is equal to the distance divided by the speed. And for Connor, the distance that he travels is 20 miles. His speed is 40 miles per hour. And if we do 20 divided by 40, that's equal to 0.5. So it should take him 0.5 hours. Or if we change that into minutes by taking the 0.5 and times it by 60, because there's 60 minutes in an hour, 0.5 times 60 is equal to 30 minutes. So it takes Connor 30 minutes to get to Belfast. Okay, now in terms of Kelly, well, Kelly drives the same distance, which is 20 miles, but she's now driving at 50 miles per hour, so she's traveling at a faster speed. So if we do 20 divided by 50, that tells us how long her journey should take. So 20 divided by 50 is equal to 0.4. Because it's 2/5, that's 0.4. So it takes her 0.4 hours. And to change 0.4 hours into minutes, we're going to take 0.4 and times it by 60. And 0.4 times 60 is equal to 24 minutes. So it takes her 24 minutes to travel from the village to Belfast. It takes Connor 30 minutes. It takes Kelly 24 minutes. So we're asked to work out how much longer it takes Connor than Kelly. So we just need to take them away. So 30 take away 24 is equal to 6. So it takes Connor 6 minutes longer to get to Belfast. And that's it. So let's write our answer down. It takes him 6 minutes longer. Okay, let's look at our next question, question number 20. So question number 20 says, Bethan drives from Truro to Taunton and it's a distance of 120 miles. She leaves at 1:40 and drives at an average speed of 50 miles per hour. And the question asks us to work out what time Bethan arrives in Taunton. Okay, so what we need to do first of all is work out how long the journey should take her. Because if we can work out how long the journey is going to take, we can then just add that on to 1:40 and find out what time she'll arrive in Taunton. Okay, so the time, the duration of the journey will be the distance divided by the speed. If we divide the distance by the speed, that'll tell us how long it'll take Bethan to get there. So the distance is 120 miles and she's driving at 50 miles per hour. And if we do 120 divided by 50, that's equal to 2.4. So it should take Bethan 2.4 hours to get from Truro to Taunton. Okay, so that's fantastic. Now, actually, because we're dealing with time here and we know she leaves at 1:40, it'd be quite nice if we had this as 2 hours and so many minutes. So we know it's going to be 2 hours because it's 2 point something. And then to change the 0.4 into minutes, we'll do 0.4 times 60, and that's equal to 24 minutes. So that means that it's going to take her 2 hours and 24 minutes. So I've just changed the 0.4 into minutes by timesing it by 60. So that's fantastic. We now know it takes Bethan 2 hours and 24 minutes to get from Truro to Taunton. So now let's do a little bit of a timeline. She leaves at 1:40, so 1:40. I'm going to add on the 2 hours to begin with. So if we add on the 2 hours, that'll be 3:40. So that's 3:40. Now there's another 24 minutes to add. So let's add on the 20 minutes, so plus 20 minutes. That'll now be 4 o'clock or 1600 hours. And there's another 4 minutes to add, so another 4 minutes. So that means that she should arrive at 4:04. So that means she should arrive at 4:04. And that's it. So what time does she arrive? 16:04, which is 4 minutes past 4 in the afternoon, or 4:04 p.m. And that's it. Okay, let's look at our next question, question number 21. Okay, let's have a look at our next question, question number 21. Now, question number 21, we're told that a dog runs 100 meters in 4.98 seconds, and we've been asked to estimate his average speed in kilometers per hour. So this dog, it runs 100 meters in 4.98 seconds, and we've been asked to estimate the dog's average speed, or his average speed, in kilometers per hour. Okay, so in terms of this question, I'm going to let the 4.98 seconds be. It's approximately equal to 5 seconds, because 4.98 seconds is really close to 5 seconds. So it's an estimate because I'm rounding that to 5 seconds. So to work out the speed of the dog, if it was traveling 100 meters in 5 seconds, we would do the speed is equal to the distance divided by the time. So it's going to be 100 meters divided by the time, which is roughly 5 seconds, and that's equal to 20 meters per second. So that means the dog's speed is approximately equal to 20 meters per second. So we now know that the dog's speed is approximately equal to 20 meters per second, but we want it as kilometers per hour. So let's change from seconds to minutes, and then from minutes to hours, and then change the meters into kilometers. So how many meters a minute would it be? Well, there's 60 seconds in a minute. So if the dog can run 20 meters in 1 second, in 60 seconds, we would do 20 times 60, and that's equal to 1,200. So that means that in 1 minute, the dog would be able to run 1,200 meters. So that means that 20 meters per second is the same as 1,200 meters per minute. We actually want kilometers per hour, not meters per minute. So now let's change to meters per hour and see how many meters per hour it would be. So the 60 minutes in an hour, so we need to times by 60 again. So 1,200 multiplied by 60 is equal to 72,000. And it's a calculator question, so you can type that bit into your calculator if you wanted to. So that means that 20 meters per second would be the same as 1,200 meters per minute, which would be the same as 72,000 meters every hour if the dog's running at that same speed. But we don't actually want meters per hour, we want kilometers per hour. So we now need to divide this by 1,000, and 72,000 divided by 1,000 is equal to 72. So that means the dog is running at 72 kilometers per hour. So that's the speed of the dog, 72 kilometers per hour. And that's it. So in this question, I just rounded the 4.98 seconds to 5 seconds. I done the distance divided by that rounded speed to give us our estimation for the speed of the dog, which was 20 meters per second. Then I changed it to 1,200 meters per minute by timesing by 60. I then times by 60 again to find out how many meters per hour. And then I divided by 1,000 to change from meters per hour to kilometers per hour. So 72 kilometers per hour. And that's it. Okay, let's have a look at our next question, question number 22. So question number 22 says, Josie departs her house in Banbridge and drives to visit her friend in Portrush. She drives a distance of 80 miles and arrives at her friend's house at 4:25 p.m. Josie assumes she drove at an average speed of 48 miles per hour. And part A says, if Josie is correct, what time did she depart Banbridge? Okay, so let's work out how long the journey should take her. Because we know the distance is 80 miles and we know she's traveling at 48 miles per hour. So if we divide 80 by 48, that'll tell us how long the journey should take her. So the time taken would be equal to the distance, which is 80, divided by the speed, which is 48. And 80 divided by 48, 80 divided by 48 is equal to 1.6666 and so on, or 1 2/3, or 1.6 recurring hours. So it means that the journey takes her 1.6 recurring hours. Now, for here, it'd be quite useful if we had it in terms of hours and minutes, because we're dealing with time here and we want to be able to do a bit of a timeline and work out what time she left Banbridge. So let's change the 1.6 recurring hours into hours and minutes. So we know it's going to be 1 hour because it's 1 point. Now we need to change the 0.6666 and so on into minutes. So let's do 0.6666 and so on multiplied by 60, and that'll change it into minutes. So times 60 is equal to 40. So that means the journey takes Josie 1 hour and 40 minutes. And actually thinking about it, there are some important ones that you should recognize. You should recognize that 0.5 is half an hour, 0.25 is a quarter of an hour, 0.75 is equal to 3/4 of an hour, 45 minutes. 0.33333 and so on is 1/3 of an hour, which is 20 minutes. And 0.66666 and so on is 2/3 of an hour. And 2/3 of an hour is 40 minutes. Or you can just do the 0.666 and so on times 60, and that's equal to 40. So it means it takes Josie 1 hour and 40 minutes to travel from Banbridge to Portrush. Okay, now we want to know what time did Josie depart Banbridge. So let's work backwards. We know she arrives at 4:25, so that's the time she arrives in Portrush. And we want to go back 1 hour and 40 minutes. So let's go back an hour to begin with. So let's take away 1 hour. So that'll be 3:25 p.m. Then we need to go back another 40 minutes. So let's take away 25 minutes. And that'll bring us to 3 p.m. And then we need to go back another 15 minutes. So go back another 15 minutes. So minus another 15 minutes would be equal to 2:45. So that means that she would have left Banbridge at 2:45 p.m. So let's write that down, 2:45. And that's it, 2:45 p.m. Okay, so let's go on down. Okay, the question then says, in fact, Josie's average speed was less than 48 miles per hour, so she didn't travel as fast as she thought she travelled. And then we're asked in part B, how does that affect the departure time? Okay, so if she's travelling at a slower speed, it'll take her longer to drive the 80 miles. So it won't be as quick. She wouldn't do the journey in 1 hour 40 minutes. It'll actually take longer. It might take 1 hour 50 or 2 hours or something like that. And then we're asked, how would that affect the departure time? Well, if it takes her longer to travel to Portrush, it means she's going to have to have left earlier, because she's going to have to leave earlier, so then she can do that longer journey in terms of time, that journey with a longer duration to get to Portrush. So because it takes her longer to travel, it means she's going to have to leave earlier, because we know she does arrive at 4:25, so she'll have to have left before 2:45. It's going to be earlier she leaves. So let's explain that. And that's it. I've just explained that the departure time would have to be earlier than 2:45 p.m. And that's it. Okay, let's look at our next question, question number 23. Okay, question number 23 says a bicycle travels at an average speed of X kilometers per hour for 3 hours. And we've been asked to write down an expression in terms of X for the total distance in kilometers travelled by the bicycle. Okay, so if we have a look at this question, the speed's been given in terms of X. Normally we may have a speed given to us perhaps 8 kilometers per hour. And then if it travels for 3 hours, we would know, well, if it travels 8 kilometers every hour, if it travels for 3 hours, we would do 8 times 3, and that's equal to 24. So it would travel 24 kilometers. If it was 10 kilometers per hour and it traveled for 3 hours, we would do 10 times 3, because it'd be 3 hours, so 3 lots of 10, and 3 times 10 would be 30 kilometers. So to find the distance traveled, we just need to do the speed times the time. So the speed is X, the time is 3, and if we times them together, that's equal to 3x. It would be 3 times whatever the speed is, so 3x, and that's it. So that would be an expression in terms of X for the total distance in kilometers travelled by the bicycle. We just times the speed by the time. That gives us the distance, and that's it. Okay, let's look at our next question, question number 24. So question number 24 says, Lee completes a journey in 3 stages. Stage 1 of his journey, he drives at an average speed of 30 kilometers per hour for 45 minutes. And part A says, how far does Lee travel in stage 1 of his journey? Okay, so we know he travels at 30 kilometers per hour and he drives for 45 minutes. So now this is a calculator question. A non-calculator approach would say, well, if he drives 30 kilometers in an hour, he would drive 15 kilometers in half an hour. So we know in 30 minutes he drives 15 kilometers. And then in 15 minutes, a quarter of an hour with half again, that would be equal to 7.5 kilometers. And then we could add the 15 kilometers and 7.5 kilometers, and that's equal to 22.5 kilometers. And that's how I would do that if I didn't have a calculator. I would just work out how far he would travel in half an hour, in 15 minutes, and then add them together. But this is a calculator question, so if I want to find out how far he travels, the distance is equal to the speed multiplied by the time. So the speed is 30 kilometers per hour, multiplied by the time. Well, it says 45 minutes. 45 minutes is 3/4 of an hour, so that's 0.75. And if we do 30 times 0.75, that's equal to 22.5. So that means that he travels 22.5 kilometers in the first stage of his journey. And then if we carry on, we're then told in stage 2 of his journey, Lee drives at an average speed of 50 kilometers per hour for 2 hours and 48 minutes. And altogether, over all 3 stages, because remember earlier on the question we were told that there's 3 stages, we're told overall, over all 3 stages, that he drives 200 kilometers in 4 hours. And then we're asked, what is his average speed in kilometers per hour in stage 3 of his journey? Okay, so if we want to work out his average speed in stage 3 of his journey, we're going to need to work out the distance and the time it takes. We want to know how far he travels in stage 3, and we also want to find out how long it will take him. Okay, so we've got stage 1, stage 2, stage 3, and then overall, so all together. So in terms of the time taken, for stage 1, if we go up, stage 1 it says that it takes him 45 minutes. So that's 45 minutes. I'm just going to write there 45 minutes, 45 minutes. Stage 2, we're told that it takes him 2 hours and 48 minutes, so 2 hours and 48 minutes. And then we're told that altogether, the 3 stages takes him 4 hours. So we know that's 4 hours altogether. So that means that we can work out how long it takes Lee for stage 3. We can work out the missing time here because we know that 45 minutes plus 2 hours 48 minutes plus this missing time is equal to 4 hours. So let's work that out. So to do that, I'm going to add together these two times here, stage 1 and stage 2, and then take that away from 4 hours. So 2 hours and 48 minutes plus 45 minutes would be equal to, let's work that out. Well, to get to 3 hours, we'd need 12 more minutes. So if we take 12 of these minutes and add them on, that'll be 3 hours. So that'll be 3 hours. And then if we reduce this by 12, we'll be left with 33 minutes. So that'll be 3 hours and 33 minutes. And to do that, I just took 12 of these minutes, added it on here to give us 3 hours, and then I'll be left with 33. So 3 hours plus 33 minutes is 3 hours, 33 minutes. Now we need to take that away from 4 hours. So 4 hours, take away 3 hours and 33 minutes would be equal to, well, to get from 3 hours and 33 minutes to 4 hours, we'd need an additional 27 minutes. So that'd be 27 minutes. So that's fantastic. We now know that stage 3 takes 27 minutes, 27 minutes. Okay, so we've dealt with the time. We know it's going to take 27 minutes. Now let's deal with the distance. So let's consider the distance. So the distances. Because we know in terms of the distances that all together he travels a distance of 200 kilometers. So it's 200 kilometers. We worked out in stage 1 that he travelled the total distance of 22.5 kilometers. So that's going to be 22.5 kilometers. Stage 2, if we go up here, we don't know the distance yet for stage 2, but we can work it out. And then hopefully then we can work out the distance for stage 3. So let's go up and have a look at stage 2. I'm just going to work in blue here for the moment. So for stage 2, we're told that he drives at an average speed of 50 kilometers per hour for 2 hours and 48 minutes. So we can work out the distance because if we do, the distance is equal to the speed multiplied by the time. And here the speed is equal to 50. And then we're going to times that by the time. Now it's 2 hours and 48 minutes. So it's going to be 2 point because it's 2 hours. Now we want to change the 48 minutes into a decimal. So we're going to do 48 divided by 60. And 48 divided by 60 is equal to 0.8. So 48 minutes is 0.8 hours. So that means that it'll be 2.8 hours. So we're going to do 50 multiplied by 2.8. And if we do 50 multiplied by 2.8, that's equal to 140. So that means that Lee travelled the distance of 140 kilometers in stage 2. So that means that this missing distance here would be 140 kilometers. And now we can work out this stage 3 distance, the one that we're trying to find. We want to find this distance here because then we can work out the speed. Okay, so let's add together the two distances we know. So let's do 140 plus 22.5, and that's equal to 162.5 kilometers. And then do 200, take away 162.5, and that's equal to 37.5. So that means that in stage 3, Lee travelled the distance of 37.5 kilometers. So that's fantastic. We now know the distance he travelled. We know how long it took him. So then we can work out the speed of the journey. So let's work that out. So the speed will be equal to the distance divided by the time. The distance will be 37.5 divided by the time. Now the time we want it to be in hours because we want it in kilometers per hour. So let's change 27 minutes into hours. So 27 divided by 60 is equal to 0.45. So that would be 0.45 hours. So we're going to do the distance, which is 37.5, divided by the time, 0.45 hours, and see what we get for his speed. So 37.5 divided by 0.45 is equal to 83.3333 and so on. So 83.3 recurring kilometers per hour. And that's it. So his speed would be 83.3 recurring kilometers per hour. And that's it. Okay, let's have a look at our next question. Question number 25. So question number 25 says, Samuel has taken part in a race that has a running stage and then a cycling stage. He completes the 35-kilometer race in 1.25 hours. Samuel completes the 5-kilometer running stage at an average speed of 12 kilometers per hour, and we've been asked to work out his average speed for the cycling stage of the race. Now we know it's a 35-kilometer race and the running stage is 5 kilometers. So that means that the cycling stage must be 30 kilometers because 30 plus 5 is equal to 35 kilometers. So we now know the length of the cycling stage. What would be great is if we knew the time it took him, because if we can find out how long it took Samuel to do the cycling stage, then we can work out his average speed. So let's consider the time. It took him 1.25 hours for the whole race, and we've got some information for the running stage. Let's see how long it takes Samuel to do the running stage. Okay, so for the running stage, we want to work out how long it's going to take him, so the time will be equal to the distance divided by the speed. So the distance is 5 kilometers and the speed is 12 kilometers per hour. So if we do 5 divided by 12, it'll tell us how long in hours it took Samuel to do the running stage of the race. So 5 divided by 12 is equal to 512, so 0.416 recurring hours. Now that's in hours. What would be great is if that was in minutes. So let's times that 0.416 recurring by 60 and see how long it takes him in minutes. So in minutes, that would take 25 minutes. So that means it took Samuel 25 minutes to do the running stage. Now the whole race took him 1.25 hours. That is in minutes, 1.25 hours. A quarter of an hour is 15 minutes. That means the whole thing took him 75 minutes. So if we do 75, take away 25, that'll tell us how many minutes it took Samuel to do the cycling stage of the race. And 75, take away 25, is equal to 50. So it took him 50 minutes to do the cycling stage. Okay, so that's fantastic. We now know for the cycling stage, its length, 30 kilometers, and we know how long it took him, 50 minutes. So we now need to find his speed. So there's a couple of approaches we could use. One approach, I'll just do both now. One approach would be to do that his speed is equal to the distance divided by the time. The distance is 30, and the time, well, we want the time in hours, so we'll divide that by 60. 50 divided by 60 is equal to 5/6, or as a decimal number, 0.83 recurring. So we divide by 0.83 recurring because that's how long it took him in hours. And 30 divided by that is equal to 36. So his speed is 36 kilometers per hour. And that's it. So we've done the distance, which was 30, divided by the time, which was 50 minutes, but we changed that into hours by dividing that by 60 to get 0.83 recurring. And then we just done 30 divided by 0.83 recurring, and we got a speed, which is 36 kilometers per hour. There was another way to do that, and that was the fact that we know that it took him 50 minutes to do 30 kilometers. So we could work out how far he would go in an hour. So I would divide both of these by 5. So we divide by 5 and divide by 5. And that'll tell us in 10 minutes he would cycle 6 kilometers by dividing both of those by 5. And then we could times both of them by 6. So times by 6 and times by 6. And that means that in 60 minutes or 1 hour, he would cycle 36 kilometers. So his speed is 36 kilometers per hour. So that's his speed, 36 kilometers per hour in the cycling stage of the race. And that's it. Okay, let's look at our next question, question number 26. So question number 26 says, the Dennison family are travelling home from the holiday. They drive 25.6 miles at an average speed of 32 miles per hour. They then drive another further 94.5 miles at an average speed of 54 miles per hour. And we've been asked to work out the total time it takes the Dennison family to return home and to give our answer in hours and minutes. Okay, so let's start off with the first stage of the journey. We've got stage 1 and stage 2. So let's start off with stage 1, the first stage. So they drive 25.6 miles at a speed of 32 miles per hour. So let's work out the time taken. The time taken will be equal to the distance divided by the speed. So the distance is 25.6 divided by the speed, which is 32 miles per hour. And that's equal to 25.6 divided by 32 is equal to 0.8. So it would take them 0.8 hours to do that first stage of the journey. Now I'm going to times that by 60 to get it in minutes, just so I can sort of interpret it a bit more easily. So if I do 0.8 multiplied by 60, that's equal to 48 minutes. So the first stage of the journey took them 48 minutes. Okay, now the second stage of the journey, stage 2. So stage 2, they drive another 94.5 miles at a speed of 54 miles per hour. So again, the time would be equal to the distance divided by the speed. The distance is 94.5 miles and the speed is 54 miles per hour. And if we do 94.5 divided by 54, that's equal to 1.75 hours. And actually, we know this one off by heart. It's 1 hour because it's 1 point. And then we've got 75, which is 3/4 of an hour, which is 45 minutes. So that means the second stage journey would take 1 hour, 45 minutes. So if we want to find the total time taken, we just need to add together these two times. We need to do 48 minutes plus 1 hour, 45 minutes. So let's do that. So 1 hour, 45 minutes plus 48 minutes. Let's see what we get. So if we add 15 minutes on, we would then have 2 hours. That would leave us with 33. So it'd be 2 hours, 33 minutes. And that's it. Okay, let's have a look at our next question. Question number 27. Question number 27, we've been asked to convert 5 kilometers per hour into meters per second. And it's a calculator question, so that's quite nice. Okay, so it's 5 kilometers per hour. Now I'm going to change it into meters per hour. So it'll be 5,000 meters per hour because there's 1,000 meters in each kilometer. Now we've got it per hour. What would be great is if we have per minute and then per second. So let's divide by 60. So divide by 60 to get it in terms of meters per minute because there's 60 minutes in an hour. So if you divide how far it travels in 1 hour by 60, it'll tell you how far you'll travel in 1 minute. So if we do 5,000 divided by 60, that's equal to 83.3 recurring meters per minute. Now that's meters in a minute. We want meters in a second, so we're going to need to divide by 60 again. So if we divide by 60, we get that's equal to 1.38 recurring meters per second. So that means that in every second you would travel 1.38 recurring meters. And that's it. So the speed would be 1.38 recurring meters per second. And that's it. Okay, let's have a look at our next question, question number 28. So question number 28, we've been asked to change 45 meters per second into kilometers per hour. Okay, so if I want to get this in kilometers per hour, I'm going to find out how many meters would be traveled in 1 hour and then change that from meters per hour to kilometers per hour. So let's times by 60 to begin with because that'll tell us meters per minute. So 45 times 60, so 60 times 45 is equal to 2,700 meters per minute. So if you travel 45 meters every second, that'll be 2,700 meters in a minute. Then if we times by 60 again, that'll tell us meters per hour. So if we do 2,700 times 60, that's equal to 162,000 meters per hour. So if you travel 45 meters every second, that's quite a big distance every second. That's equal to 162,000 meters every hour. And then if we divide that by 1,000, that'll be 162 kilometers per hour because there's 1,000 meters in every kilometer. So if you divide that by 1,000, that'll be 162 kilometers per hour. So 162 kilometers per hour. And that's it. Okay, let's go to the next question, question number 29. So question number 29 says the speed limit on a road is 50 miles per hour and a car travels 19 miles in 22 minutes. Is the car breaking the speed limit? You must show your workings. Okay, now there's a couple of approaches that we could use for this question, and I'm going to do both of them in this video just to show you either approach. So the first thing we could do is we could say, well, if you drive 19 miles in 22 minutes, what would it be in an hour? So how far would you travel in an hour? Because that would be your speed, so many miles per hour. So let's divide by 22 and divide by 22 because that would tell us how many miles in 1 minute. So that'd be how many miles in 1 minute. So 22 minutes divided by 22 is 1 minute. So that's how far you travel in 1 minute. And if we do 19 divided by 22, that's equal to 1920 seconds or 0.8636363 and so on. Now that's in 1 minute. We want it to be in an hour, so let's times by 60 and times by 60. And we times both of them by 60, we'd have 1 hour. So we'd have 1 hour as the time, and then 0.8636363 and so on times 60 would be 51.8181 and so on miles. So that means it would be 51.818181 and so on miles per hour. So that's the speed, 51.8181 and so on miles per hour. And the question says, is the car breaking the speed limit? The speed limit is 50 miles per hour. So yes, the car is breaking the speed limit because 51.81 recurring is greater than 50. So yes, the car is breaking the speed limit. So that's one way you could approach that question, to consider how far would the car travel in 1 minute, how far would the car travel in 1 hour? And then that's the speed in miles per hour. And that's it. Okay, now there's another approach to that question. Another approach to that question is to just consider that the speed is equal to distance divided by time. So the distance is 19 and the time, well, we want the time in hours, so we need to change the 22 minutes into hours. So 22 divided by 60 is equal to 22 divided by 60 would be 0.36 recurring hours. So 0.36666666 and so on hours is equal to 22 minutes. So that means the distance is 19, the time is 0.36 recurring, and if we do 19 divided by 0.36 recurring, we get an answer of 51.8181 and so on miles per hour. And 51.818181 and so on miles per hour is greater than 50 miles per hour, so the car is breaking the speed limit. And that's it. Okay, let's look at our next question, question number 30. Okay, so question number 30 says that drone A has a maximum speed of 35 miles per hour and drone B has a maximum speed of 57 miles per hour. And we're told that 1 mile is approximately 1.6 kilometers, and we've been asked which drone has the greatest maximum speed. Show your workings. Okay, so here the two speeds are in different units. One's in miles per hour and one's in kilometers per hour. So let's convert them. So we can change either the miles per hour into kilometers per hour. And to do that, you would just times the 35 by 1.6, because if it travels 35 miles every hour, that's going to be 35 lots of 1.6. So 35 multiplied by 1.6 is equal to 35 times 1.6 is equal to 56. So it would travel 56 kilometers in an hour. So that's 56 kilometers per hour. So that means that drone A would have a speed of 56 kilometers per hour. Drone B has got a speed of 57 kilometers per hour. So drone B has the greatest maximum speed. And that's it. Alternatively, we could divide the 57 by 1.6 because that would tell us how many miles per hour. And if we do 57 divided by 1.6, that's equal to 57 divided by 1.6 is equal to 35.625 miles per hour. And so that means that that speed of 57 kilometers per hour is approximately equal to 35.625 miles per hour, which is greater than 35. So again, drone B would have the greater maximum speed. And that's it. You only obviously need to use one of these approaches. You can either change this into kilometers per hour or that into miles per hour and then see which one's got the greatest maximum speed, which is drone B. Okay, let's look at our next question, question number 31. So question number 31 says, Isla runs 800 meters in 2 minutes and Olivia cycles 800 meters at a speed of 30 kilometers per hour. And the question says, work out how much less time it takes Olivia than Isla to travel that 800 meters. Okay, so we want to work out how much less time it takes Olivia than Isla, and obviously Olivia cycles, so she's going to do it probably more quickly than Isla. So let's work out how long it takes each of them. Now for Isla, we're told that she runs 800 meters in 2 minutes, which is 120 seconds. So Isla runs 800 meters in 2 minutes, which is 120 seconds. Now in terms of Olivia, let's just write down here Olivia, she cycles 800 meters at a speed of 30 kilometers per hour. Now we want to find the time taken, but we've got a bit of a problem here. We've got 800 meters and 30 kilometers per hour. So what I'm going to do is I'm going to change this speed from kilometers per hour into meters per second. So let's convert the 30 kilometers per hour into meters per second. So it's going to be 30 kilometers per hour. Let's change that into meters. So to change from kilometers into meters, we're going to times by 1,000. So that's going to be 30,000 meters per hour. So that's how many meters per hour. Let's work out how many meters per minute. So let's divide by 60. So if we divide by 60, so divide by 60. And I'm just going to get my calculator and do 30,000 divided by 60. And that's equal to 500. So that's 500 meters per minute instead of meters per hour. Now that's meters per minute. We're going to divide by 60 again now to work out how many meters it'll be per second. So 500 divided by 60 is equal to 8 1/3, 8.3 recurring meters per second. So that's Olivia's speed. She's cycling at 8.3 recurring meters per second. Now we want to work out how much time it's going to take her. So let's work out the time. So the time's equal to the distance traveled divided by the speed. So the distance is 800 meters and we're going to divide that by 8.3 recurring, the speed. And when we do that, we get an answer of 800 divided by answer is equal to 96 seconds. So it takes Olivia 96 seconds to cycle the 800 meters. And it takes Olivia 2 minutes, which is 120 seconds. Now we're asked to work out how much less time it takes Olivia than Isla, so let's subtract them. 120 take away 96 is equal to 24. And that's it. So it takes Olivia 24 seconds less to complete the 100 meters than Ella. So let's write that down, 24 seconds. And that's it. Okay, let's look at our next question, question number 32. So question number 32 says, Maxwell drives for 20 minutes at an average speed of 30 miles per hour. And then we're told that he joins the main road and drives at an average speed of 48 miles per hour for the next 45 minutes. And Hayden drives the same distance as Maxwell on the motorway, and it takes him 17 minutes less time. And we've been asked to work out Hayden's average speed. Okay, so let's start off by looking at Maxwell here. So Maxwell. He's got two stages of his journey. He's got stage 1 and stage 2. Now we're told that Hayden drives the same distance. So if we can work out how far Maxwell travels, then we'll know how far Hayden travels. So let's work out the distance Maxwell travels. He travels for 20 minutes at a speed of 30 miles per hour. So to work out the distance travelled, we normally do the speed times the time. So we're going to do the speed, which is 30 miles per hour, multiplied by the time. Now the time is going to be in hours here. This is 20 minutes, and 20 minutes is a third of an hour, or 0.333, and so on. So here what you can do is, if you wanted to, you could divide the 20 by 60 to change the minutes into hours, and that's going to be a third, so a third of an hour, or you could just recognize that that's a third of an hour. So we're going to do the speed, which is 30 miles per hour, multiplied by the time, which is a third of an hour, and that's equal to 10. And that means that he travels 10 miles in the first stage of his journey. And that actually makes sense, because if he travels 30 miles in an hour, or 30 miles per hour, that's 30 miles in 60 minutes. To go from 60 minutes to 20 minutes, we divide by 3. So if we divide the distance by 3, that'll be 10 miles. And that's what we got. Okay, so that was the first stage. So that was 10 miles. Okay, so let's have a look at the next stage. So he joins the main road and drives at a speed of 48 miles per hour for the next 45 minutes. So the distance is going to be the speed times the time. We want to find the distance again here. The speed, well, it's 48 miles per hour, so it's 48, multiplied by the time. Well, the time taken, well, that's 45 minutes, which is 3/4 of an hour. So we're going to times by 3/4, or 0.75. So if we do 48 multiplied by 3/4, or 0.75, we get that's equal to 36. So it's 36 miles. So that means that he travels 10 miles in the first part of the journey and 36 miles in the second part of the journey. So altogether, that'll be 46 miles. So that means that Maxwell travels a total distance of 46 miles. Okay, so we now have worked out how far Maxwell drives. He drives a distance of 46 miles. Now if we go down here, we're told that Hayden drives the same distance. So Hayden drives the same distance, so he drives 46 miles as well. So he's going to drive 46 miles. If we just write down here, Hayden. So Hayden travels 46 miles. And then we're told it's on the motorway and it takes him 17 less minutes. So let's work out how much time it takes Maxwell to drive. So let's go back to the red ink. It was 20 minutes for the first part of the journey and 45 minutes for the second part of the journey. So 20 plus 45, 20 plus 45 is equal to 65 minutes, 65 minutes. So that's how long Maxwell was driving for, 65 minutes. Now we're told that Hayden drives that distance in 17 less minutes. So let's go back to blue here. So if we do 65, take away 17, that's how long Hayden was driving for. And 65 take away 17 is equal to 48 minutes. So that means that Hayden done the distance of 46 miles in 48 minutes. Okay, so we now know for Hayden the distance he travelled, 46 miles. We know the time it took him, 48 minutes. Now we want to work out his average speed. So to work out the speed, we do distance divided by time. So the distance is obviously 46, but we need to divide that by the time in hours. Now it's 48 minutes, so if we do 48 divided by 60, that'll tell us the time in hours. And 48 divided by 60 is equal to 0.8, so it's 4/5 of an hour. So it's 0.8 hours, or 4/5 of an hour. So that means that the time taken was 0.8 hours, or 4/5 of an hour. So if we do the distance, 46, divided by the time, 0.8 hours, that'll tell us Hayden's average speed. And 46 divided by 0.8 is equal to 57.5 miles per hour. So that's Hayden's average speed on the motorway. And that's it. Okay, let's look at our last question, question number 33. So question number 33 says, a motorbike and a car take part in a race along a straight road. So there's a straight road and they're taking part in a race. The distance between the start line and the finish line is 8 miles. So it's an 8-mile race. The motorbike crosses the start line at 50 miles per hour and stays at that speed. So the motorbike, it crosses the starting line at 50 miles per hour and it stays at that speed the whole time. So a whole 8 miles. Then we're told that 1 minute later, the car crosses the start line travelling at a certain speed. So we don't know the speed that the car is travelling at, but it's travelling at a certain speed and remains at that speed. So that means that the car starts a minute after the motorbike. So the motorbike's been given a bit of a head start and it's travelling at 50 miles per hour. And then a minute later, the car crosses the start line at a certain speed and carries on at that speed. And then we're told after 2 more minutes, the car overtakes the motorbike. So that means the car must be going at a faster speed than the motorbike because it's caught up with it and it's taken 2 minutes to catch up with it. So the car's been travelling for 2 minutes and it's caught up with the motorbike. And the motorbike, that means it's been travelling for 3 minutes because we were told that it crossed the start line at 50 miles per hour and a minute later the car started. And then after 2 more minutes, that's 3 minutes altogether, the car overtakes the motorbike. So the motorbike's been travelling for 3 minutes and the car's been travelling for 2 minutes at that faster speed. And then we're asked, how long after the car crosses the finish line does the motorbike cross the finish line? Because obviously the car's running at a faster speed and it's overtaken the motorbike. So the car's going to cross the finish line first and then the motorbike's going to cross the finishing line, and we're asked for that time difference. How long after the car crossing the finishing line does the motorbike cross the finishing line? Okay, so the first thing I notice here is that the motorbike, it's been traveling at 50 miles per hour for 3 minutes whenever the car catches up with it. So if we can work out how far the motorbike has travelled in that first 3 minutes, we can then work out the speed the car's travelling at, because we will know how far the car's travelled in its first 2 minutes, because remember it started a minute later, and then we'll know that it's travelled whatever distance that is in 2 minutes. So we can then work out its speed. Then we can use that information, the speed of the car and the speed of the motorbike, to work out how long they'll take to cross the finishing line. Okay, so let's start off with the motorbike. So we're going to look at the motorbike. And what we're going to do is we're going to concentrate on the fact that it was travelling at 50 miles per hour for 3 minutes whenever the car caught up with it. So let's work out how far it travelled in that time. So the distance will be equal to the speed, which is equal to 50 miles per hour, so 50, multiplied by the time taken. Now the time taken is 3 minutes. We want it in hours, so we're going to do 3 divided by 60. And 3 divided by 60 is equal to 0.05. So that's 0.05 hours. So if we do 50 times 0.05, that'll tell us how far the motorbike's travelled in the first 3 minutes. So 50 multiplied by 0.05 is equal to 2.5 miles, 2.5 miles. So that means that the motorbike, it travelled for 3 minutes. So it travelled for 3 minutes, the first minute on its own, and then for 2 more minutes, and then the car caught up with it. And so after 3 minutes, it had travelled 2.5 miles. Now that means that the car, remember it started a minute after the motorbike and it just drove for 2 minutes and it caught up with that motorbike. And it travelled a distance of 2.5 miles. So we know that it travelled 2.5 miles in 2 minutes. So that's going to help us out. So let's write that down. The car. So I've just written down for the car that it took it 2 minutes to travel 2.5 miles. So if we know the time and the distance, we can work out the speed. The speed is equal to the distance divided by the time. The distance is 2.5 miles divided by the time. Now the time again is in minutes, so we're going to need to change 2 minutes into hours. So 2 divided by 60. And 2 divided by 60 is equal to 0.03 recurring, so 0.033333 and so on, hours. So we're going to do 2.5 divided by 0.3 recurring. So 2.5 divided by answer is equal to 75 miles per hour. So that means the car is travelling at 75 miles per hour. So that's fantastic. We now know the speed that the motorbike's travelling, which is 50 miles per hour, and we know the speed the car's travelling, which is 75 miles per hour. But also remember the car started a minute after the motorbike, so that's going to be important as well. Okay, so we now know the speed of both vehicles, 50 miles per hour and 75 miles per hour. Let's see how long it take each of them to travel the 8 miles. Now we'll come back to the fact that the motorbike was given a 1 minute head start in a moment. I was going to say in a minute, that'd be confusing, a minute's head start in a minute. But I'm going to come back to the fact that the motorbike was given a minute's head start in a moment. But what I'm going to do is I'm going to work out how long it would take each of these vehicles to travel 8 miles, because remember the journey, the race was 8 miles. So let's work out how long it would take the motorbike and the car to travel 8 miles. And then we'll come back to that head start in a minute. Okay, so in terms of the motorbike, it's 8 miles, so the time taken will be equal to the distance divided by the speed. The distance is 8 miles, and we're going to divide that by the speed, which is 50 miles per hour. So if we do 8 divided by 50, that'll be the time taken. And 8 divided by 50 is equal to 0.16, so 0.16 hours, because remember here the distance is in miles but the speed was in miles per hour, so the answer would be in hours. So that's 0.16 hours. Now I'm going to times that by 60, and that's equal to 9.6 minutes. So 9.6 minutes. So that's how long it would take the motorbike to travel 8 miles. Now let's look at the car. The car, its time is going to be calculated by doing the distance divided by the speed. The distance again is 8 and its speed was 75 miles per hour. So we're going to do 8 divided by 75. So 8 divided by 75 is equal to 0.106 recurring hours. But we want it in minutes, so we're going to times by 60, and that's equal to 6.4 minutes. 6.4 minutes. Okay, so that's fantastic. We now know how long each vehicle would take to cover the 8 miles, but now we need to consider the fact that the motorbike was given a 1 minute head start. So from the minute they say go and the motorbike crosses the start line, it took 9.6 minutes. But the car had to wait a minute and then cross the starting line. So from the very beginning, it had to wait a minute and then it would take 6.4 minutes. So if we do 6.4, so if we take the 6.4 minutes and add 1 to it, that's how long after saying go the car would take. So that'll be 7.4 minutes. So that means that from the moment they say go in terms of this race, the car would take a total of 7.4 minutes because it had to wait a minute and then it took 6.4 minutes to complete the race. Whereas the motorbike, it was going from the beginning at a slower speed and it took 9.6 minutes. So now we can take them away. We can do 9.6 take away 7.4 and that's equal to 2.2. So that means that the motorbike crosses the finishing line 2.2 minutes after the car, because the car had to wait a minute and then it took 6.4 minutes. So from the start of the race, it took 7.4 minutes to cross the finishing line. But the motorbike, it took 9.6 minutes, which was a bit slower. So it was 2.2 minutes slower. And then that's in minutes. You could give your answer. I'm just going to go up and check. It didn't say we had to give our answer in seconds. So you could give your answer as 2.2 minutes there. I'm going to times that by 60. So I'm going to do 2.2 times 60. And that's equal to 2.2 times 60 is equal to 132. So across the finishing line 132 seconds after the car, and that's it. So I just changed that 2.2 minutes into seconds, and that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on speed, distance and time. If you need any extra help on speed, distance and time, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video number 299, there's a dedicated video tutorial there on speed. Alternatively, you can scan this QR code. But in this video, we focus on the video solutions to the practice questions. I really hope you found this video useful. And if you have found it useful, please like and please subscribe to my YouTube channel. Thank you. Cheers. Bye.